Have you ever looked up at the daytime sky and been greeted by an unexpected sight? The moon, a silvery disk against the blue? It's a sight that can stop you in your tracks, making you wonder about the mysteries of the universe. It's a phenomenon that often sparks curiosity and wonder in both young and old alike. Why do we sometimes see the moon during the day? This question has intrigued humanity for centuries. We tend to associate the moon with the darkness of night, a companion to the stars. Yet, this celestial neighbor often graces our skies during daylight hours, creating a beautiful contrast against the bright sky. This seeming contradiction arises from a fascinating interplay of light, orbits, and our own planet's movements. The dance of celestial bodies is more complex than it appears. Understanding why we see the moon during the day deepens our appreciation for the dynamic nature of our solar system. It reveals the intricate mechanics of our cosmic neighborhood. It reminds us that the cosmos is in constant motion, a celestial ballet of objects interacting across vast distances. Every moment, the universe is changing. So let's embark on a journey to unravel the secrets behind the moon's daytime appearances. Together, we'll explore the science and the beauty of this phenomenon. We'll delve into the science that governs its visibility, revealing the factors that make this celestial wonder visible, even when the sun holds court in the sky. Join us as we uncover the mysteries of the daytime moon. The moon, unlike the stars that pepper the cosmos, doesn't possess its own light. Instead, it shines with a borrowed brilliance, reflecting the light of our sun. Just as a mirror reflects light, the moon's surface acts as a celestial reflector. Sunlight strikes the lunar surface and bounces off, illuminating the moon and making it visible from Earth. This reflection is the key to understanding why we see the moon both at night and, surprisingly, during the day. The moon's illuminated face is always pointing towards the sun, even when it shares the sky with its radiant source. The amount of reflected sunlight we see depends on the moon's position in its orbit around Earth, giving rise to the familiar cycle of lunar phases. However, even a partially illuminated moon can be bright enough to be seen against the backdrop of the daytime sky. Earth's rotation on its axis is what gives us the cycle of day and night. As our planet spins, the sun appears to rise in the east and set in the west. The moon too follows this apparent motion across the sky. However, the moon isn't stationary. It's locked in a celestial dance around Earth, orbiting our planet over a period of about 29.5 days. This orbital motion means that the moon's position relative to the sun and Earth is constantly changing. This interplay between Earth's rotation and the moon's orbit means that the moon isn't confined to appearing only at night. Sometimes its celestial path brings it into our field of view during daylight hours. Imagine a grand waltz with Earth spinning as it's orbited by the moon. Their movements are synchronized yet distinct, resulting in moments when the moon graces our daytime sky as a luminous companion to the sun. As the moon orbits Earth, the angle at which the sun's light strikes its surface changes from our perspective, creating a fascinating dance of light and shadow. This variation in illumination gives rise to the lunar phases, from the new moon, when it's hidden from view, to the full moon, a radiant disk in the night sky. Each phase has its own unique beauty and significance. The moon's phase plays a crucial role in its daytime visibility. Depending on its position relative to the Earth and the sun, we can sometimes see the moon during the day. During a full moon, the moon is opposite the sun in the sky, creating a striking contrast. As the sun sets, the full moon rises, and vice versa. This celestial choreography is a beautiful reminder of the interconnectedness of our solar system. Therefore, we wouldn't expect to see a full moon during the day. Its brilliance is reserved for the night. However, during other phases, such as the first quarter and last quarter, when the moon appears as a half circle, it's not uncommon to spot it in the daytime sky. These phases offer a unique opportunity to observe the moon against the backdrop of daylight. At these times, the moon is positioned at a right angle to the sun, making its illuminated portion visible against the blue. This right-angle positioning is key to its visibility during the day. The crescent phases, both waxing and waning, can also be spotted during the day, though their thinner sliver of light makes them more challenging to discern against the bright sky. These delicate crescents add a touch of mystery to the daytime sky. Section 5. The veil of air, atmospheric scattering. Earth's atmosphere, a delicate shroud of gases surrounding our planet, plays a crucial role in our ability to see the moon during the day. This thin layer of air is composed of nitrogen, oxygen, and other trace gases, creating a protective blanket around Earth. While it might seem counterintuitive, the very air we breathe can both hinder and aid our view of celestial objects. The atmosphere acts as a filter, scattering light in various directions. When sunlight enters the atmosphere, it's scattered by the tiny particles of gas that make up the air. This phenomenon is known as Rayleigh scattering. This scattering is more pronounced for shorter wavelengths of light, such as blue and violet. As a result, these colors are scattered in all directions, giving the sky its characteristic blue hue. That's why the sky appears blue during the day. Scattered blue light reaches our eyes from all directions. The effect is so pervasive that it masks the presence of stars. This scattering effect can make it more challenging to see fainter objects, like stars, during the day. The overwhelming brightness of the scattered sunlight drowns out the faint starlight. The scattered sunlight overwhelms their dim light, making them nearly invisible to the naked eye. However, the moon's surface is much brighter than that of stars. Its albedo, or reflectivity, is high enough to stand out against the scattered sunlight. Its reflected light is often strong enough to pierce through the veil of scattered sunlight, making it visible even against the blue backdrop. This is why we can often see the moon during the day, a testament to the fascinating interplay of light and atmosphere. Section 6. Shining through, surface brightness, and the moon's visibility. The moon's proximity to Earth, compared to the vast distances to stars, gives it a visual advantage. This advantage lies in its surface brightness, a measure of how much light an object emits per unit area. Even though the moon reflects only a small percentage of the sunlight that falls upon it, its surface brightness is relatively high because it's so close to us. This brightness is crucial for its daytime visibility. Think of it this way: imagine shining a flashlight on a white wall in a brightly lit room. The illuminated spot on the wall, despite being surrounded by light, stands out because it has a higher surface brightness than its surroundings. Similarly, the moon's surface brightness often exceeds that of the daytime sky, allowing it to stand out against the blue, even when the sun bathes the atmosphere in light. Section 7. Catching a glimpse. Tips for daytime moon observations. While the moon's appearance in the daytime sky might seem random, there are optimal times and conditions that increase your chances of spotting it. Look during the first and last quarter phases. When the moon is half illuminated, it's often high enough in the sky during the day to be visible. Seek clear skies. Clouds can obscure the moon, making it impossible to see. Choose a day with clear or mostly clear skies for the best viewing. Consider the time of day. The moon's visibility can vary depending on its position relative to the sun. Experiment with looking at different times of day to see when it's most apparent. Scan the skies. Don't expect the moon to be as obvious during the day as it is at night. Scan the sky slowly and carefully, and you might be rewarded with a glimpse of this celestial wonder. Section 8. Conclusion. Our celestial companion, day and night. The moon, our constant celestial companion, isn't confined to the realm of darkness. Its presence in the daytime sky is a testament to the dynamic interplay of light, orbits, and our own planet's motions. Understanding why we see the moon during the day deepens our appreciation for the intricate workings of our solar system. It reminds us that the cosmos is a stage of constant motion, where celestial objects engage in a graceful dance across vast distances. So, next time you find yourself gazing at the daytime sky, take a moment to search for the moon. Its silvery disk against the blue is a reminder that wonder can be found not just in the darkness of night, but also in the brilliance of day. Keep looking up and exploring the wonders of the universe above.